Hey guys, welcome to your first lab. This will be very quick, very short, kind of a setup to the rest of our labs. So you can think of this experiment, or I should say demonstration, as a warm-up for the rest of the course. One of the first things we do in the Chemistry 2770 labs is show you guys how to properly collect a water sample. So that's what this lab is about, how to collect a water sample. Now, when I am talking about collecting a sample, this is environmental chemistry. So these samples would come from the environment, a lake, a river, the ocean, and we would ideally go to the source and collect these samples. And again, ideally, we would want to test these samples at the source. And that's a really important thing to know about water sampling and test quality in general, is time as a consideration. When you collect a sample, so if I went down to, say, the Corniche and filled this water bottle up, time can be an issue. The time it takes to drive this sample back to the lab could be a factor with my experiment. It could affect the results. So if I was measuring something, and we'll talk a little bit more about this in the course, but something like dissolved oxygen or pH that was affected by temperature, we're seeing temperature changes when we remove it from the source and bring it back to the lab. So ideally, every sample you collect, you want to collect that sample at the source and test it right there. So you'll see in the upcoming labs, most of our equipment isn't normal lab equipment. It's what's called a test kit. And it's in this big briefcase, and all of this equipment can be brought to the source. So you can test it right there, right at the source, and get the best results possible. We're not risking contamination, bringing it back to the lab, or we're not harming any of the chemical or biological properties by transporting this chemical, 10, 15 kilometers away, bringing it into a lab. We're testing it right there at the source. So we will, in this lab, use a variety of equipment that's portable. The test kits we can bring to the source, something like this, which we'll use a little later, like a portable pH meter. We can bring that, stick it right in the water, test it at the source. Again, the reason for this is quality. Okay, we want to make sure our sample is as clean, as pure, and as accurate as possible. We want it to reflect the sample. We don't want to bring it back to a lab. We want to test it where it is. Another big issue that there is with sampling is contamination from the equipment you're using. So, this might not be perfectly clean. This is a pH meter. This bottle might not be perfectly clean. I rinsed this with tap water, and then in the lab when I took it, I rinsed it with deionized water, but it's still not the best vessel for sampling. You can see even inside there's some condensation. So this lab, this experiment, I'm going to show you how to properly collect a sample. And if we were on campus, we would then go outside. We would collect these from, the water fountains outside, maybe the swimming pool in the gyms, and go back to the lab and test them. So I'm going to kind of fake it here. I have a big container of tap water, but I will show you how to properly clean and collect a sample. Okay, so there are six steps. Okay, you should know these steps, wink, wink. 6 steps to properly collecting a sample. And step number 1 is something that we would also do in the lab when you clean something like a burette or a pipette. You always want to clean your vessel with the sample you're testing. So this has been cleaned, like I mentioned, with deionized water and tap water. Tap water first, then deionized. But I want to make sure it's cleaned with the sample. So any liquid, anything in here is from my sample itself. So step number 1 is rinse this bottle in your sample. Now, this is not a really good representation. Ideally, our sample would be a large body of water, right? A lake, a stream. Go down to the corniche, dip it in, and then pour it out maybe on the side, not back right into the water, but on the beach or on the shore. So my first step is obviously take the top off and rinse this out. Again, not the best example because the minute I do this, I'm technically contaminating this small amount of water. Just pretend this is the ocean or a large lake or river. So I collect some water, I'm gonna rinse it out, I'm gonna clean the cap, right? Make sure everything's clean. You can dip the cap in as well. Rinse, rinse, rinse. And you would probably want to do this 2-3 times, the more times the better. Once I collect this, well, not collect the sample, but clean this, I will then dump this away from my source. So I'm just gonna go to my sink. I'm in my kitchen, but you dump this away. So back in 1 second. Okay, so you can see, it's wet on the inside. That's totally normal. Wet on the outside. We're not trying to make this dry. It should be wet with my sample. Step 2. So step 1, clean your bottle, your collection vessel with the source, with what you're trying to test. Step 2, put the top on. You don't have to put it on too tight, excuse me, but we're gonna put the top on and we're going to lower it into our water sample. Step 3, I'm going to remove the cap and then I'm going to let it fill. You can hear it filling. I'm going to let it fill with the water. So step 1, I'm cleaning it. Step 2, put the top on, put the cap on. Step 3, let it fill in my source. Okay, you can keep the cap in here as well. Step 4, tap the bottle to get rid of any air bubbles. Remember, we're not testing air. We don't want air in this sample. We want pure, 100% water in this bottle. This sampling procedure, by the way, is typically if we had to bring this back to a lab. So, if I was near the ocean and I wanted to test the temperature, pH, dissolved oxygen, I could just put the meter right into the water, right? Depending on the equipment you have, that's fine. But this type of sampling procedure is so I can take this sample back to the lab and have it, as clean, the least contamination as possible. So I'm flicking out any air bubbles. I can see a couple in here. Okay. All right. So that's step 4. Step 5, replace the cap while it's still submerged. I can still see some air bubbles coming out, guys. This is not the best vessel to do this. So replace the cap while it's still submerged. And then step 6, obviously, retrieve your sample and make sure there's no air bubbles in it. And you can see, again, this would be a lot easier if I had a lot more water. The pressure would force all of that water in. There shouldn't be any air up here. Let me just see if I can push it to the bottom and fill it all. Again, if I had a bigger container, the pressure would force all the water in. So this is not the best example. You can kind of see at the top of my fingers, the water is not completely going into the bottle here. That's not good. But if we were, at the fountains at school, you could really dip that sample in and this would completely fill with water. Okay, so let me just go over the steps again. Ideally, guys, this is bad. This air up top we do not want. So I would need a bigger container. I would dip it deep into the container and it would completely fill. I could probably use my sink or a bathtub, but you wouldn't be able to see through. So we'll just pretend that there's no air in that sample. And I've done these labs so many times with students, it works perfectly. This thing would be completely full. So we don't want any air here. So let me just go over the steps again really quick because you do need to know these. And then I'll mention one more thing about the next lab, about testing this sample now, and then that'll be it. So step 1, rinse this bottle with your sample, you know, with the source. So a lake, a river, a stream, a fountain, a swimming pool. Rinse this out, pour it away. Step 2, put the top on the bottle first, and then step 3, lower it in here. Step 1, rinse. Step 2, put the top on. Step 3, put it in and take the top off and let it fill. Step 4, tap this to remove any air bubbles. Step 5, put the cap back on this. And then step 6, remove and make sure there's no air in this bottle. And again, you can see that I'd have to do this sample again if this was in the lab. Last thing I'll mention, and this is it for this is like our warm-up lab, I guess, getting us ready for the next little bit. The last thing I'll mention is, now that I have my sample, if I was going to start the next lab, testing dissolved oxygen, I wouldn't ever, and this is for environmental chemistry, or just chemistry in general, I wouldn't ever test it in this bottle. This, pretending there's no air in here, is our pure collected sample. This is like our goals. We keep this and we use this for all the other tests. But we do the other tests in clean other glassware or other equipment. So I have a graduated cylinder here, for example. It's been cleaned. What I would do to test this is I would again rinse my, this could be a beaker, this could be an Erlenmeyer flask. This is just what I have next to me. So I would again rinse this with my sample. Okay, rinse it up. Pour it down the sink. You wouldn't pour it back in here, but pour it down the sink. Now, if I wanted to test something like, say, temperature, I have this is a kitchen, like a meat thermometer, but it works really well. So if I wanted to test the temperature or the pH, I would test it in here, not in this bottle. If I stuck this in the bottle, I'm now contaminating my pure sample. Pure is maybe not the right word, but you know, my sample that has been taken from the source and has not been contaminated. If I put this in here, I'm affecting the results here. There could be some chemicals left on this. So if I wanted to, say, test the pH, I would pour my sample into my now clean beaker, Erlenmeyer flask, whatever you have, and then now I can do all my testing. Okay? Chemistry is all about repeatable results. You want to make sure you have clean glassware, no contamination. Remember, this equipment is used by hundreds of students a semester, so it needs to be cleaned properly before we do any sampling. Any type of contamination, your results are gone, they're ruined. So you want to make sure you collect your sample properly in a cleaned bottle, and then do the lab properly in a cleaned bit of glassware. So that's kind of it for the first lab, or first, I guess, demo. And then next week, now that we know how to collect the sample, we're going to do tests. And this semester, we'll look at things like pH, dissolved solids, dissolved oxygen, nitrates and phosphates. Maybe we'll see if that's going to work out. And I think next week I'll try to get a good sample from maybe another source, maybe a swimming pool or something like that. So that's it for today's experiment. There is a little quiz on D2L about what you've seen here. So yeah, good luck. And if you have any questions, you can send me an email and let me know. All right, see you in class. Bye-bye.